Hello, everybody. Good morning, good afternoon, good evening, wherever you are. Thank you very much for joining us. We are here on time, but let's give another few seconds to a minute to others to join so they can be here with us. So we'll be silent for a little bit and then we'll come back. But thank you for joining us on time. Thank you. So let's start. My name is Boris. I'll be your host for the next hour. Together with me is Yuval. Yuval is our CTO at K2view. Very quick round of introductions. Yuval has many years of building complex products for enterprises and also managing very large teams of developers. And I have to tell you that he's very good at that. In terms of interests, he's very interested in cutting edge technologies. And for the last number of years, he worked with AI-related technologies such as LLMs, chain of thought, generative data products. So Yuval is very well versed in the subject, and he guides the company to new development and very interesting products delivered to market. My background is more on the enterprise side. Over the many years, I worked with data integration across different markets: banking, finance, insurance, telecom. And I also enjoy AI very much. And specifically, I'm interested in how AI is changing and will be changing even more the way we build software, and also how it impacts the enterprise architectures. So these are introductions. Let's dive to the next slide, which is what are we going to cover today. Agenda is very simple. We'll first try to frame the notion of MCP. And first of all, MCP stands for Model Context Protocol. So if this is something you didn't expect, probably it's a good time to either change what you're doing right now or stay with us and hopefully learn a little bit more about this very exciting subject. So first, we're going to frame what MCP is, give it a little bit of a background, what role it plays in agentic AI, and why is it so important as a building block for building larger architectures. The second topic that we're going to cover, we're going to see how MCP fits into the overall enterprise architecture and how agentic AI is changing the enterprise architecture and what are the right approaches. And we'll share with you what we learned. We have a lot of practice in this, and hopefully our experiences in this field will be helpful. And then after that, we're going to have a demo, which we're going to go and show you the product, how MCP works with the product in several use case scenarios, and hopefully that will be very useful. Throughout this process, you have a link on the bottom of your screen, which is a link for questions. Feel free to add questions as we go along. We'll see if the questions sort of like fit the narrative, and we'll try to answer it during the talk. But if not, we'll leave a few minutes at the end of the session to cover some of the questions. If we don't cover them, then we'll get back to you with the answers over the email. So with that, let's dive into the interesting part of what we're here for. To step back, right, and just capture the moment. The moment is very unique in the technological history of where we are. A lot of people refer to this year, 2025, as the year of AI agents, right? And you probably, if you're listening to podcasts, if you're reading technical literature, it will be quite obvious to you that that's what, one of the most talked points on a subject. And a lot of people agree with this. Some of the people disagree, whether we're already in the age of AI agents. But what is pretty clear is that it's inevitable, right? It's inevitable that agentic AI or agentic architecture is going to be something that we're going to be converging to. So let's take this moment and sort of contrast the way we develop software today with the way that agentic architecture will be practiced a few years from now, let's say. If we look at the way that traditional architectures are organized today, it's quite simple, and we're all familiar with that, right? So we have, if you look at this slide on the left side, we have a data tier, persistence tier, where we store the data, and it could be databases, files, and so forth. Then we have a layer of business logic, and this is something we can program and develop in a particular language. We can have workflows, we can have other means of expressing the logic. And then above that, we have UI, right? So this three-tier approach is sort of like how every traditional application looks like. It's very different with AI, right? With AI, the way that we see the future architecture is that databases remain, right? Because databases is effectively a source of definitive data, right? Databases express and capture it, and we can rely on it. But then above that line of persistence, the actual business logic is something that is going to be performed and accomplished by AI, right? In form of AI agents or some other form, right? And structure of that approach is very different than today. Today, we hard code the logic. With agentic AI, we really give context and intent to the agents. And then there is a digital brain which sits behind the curtain, right? And it orchestrates what is the next action, how those agents are interacting with each other, and how they accomplish the task. And it's a very different way of architecting the software. And therefore, it's good to be both ready for this kind of transition, but also starting to learn and practicing this kind of approach to building new types of applications to complement what we're doing today.
So, again, this is an exciting future. Does this future completely replace what we have today, or how are things going to shape up?
Great question. Thank you, Yuval. So I'm sure everybody in the audience have their own notion of what the future looks like. I have a pretty radical notion that at some point in time, agents or whatever form of agentic or AI infrastructure we have is going to be responsible for end-to-end implementation and operation of the software. But in my mind, we're still quite a few years away from that. But it would be interesting with this lens, Yuval, jump into sort of like the next level of detail and explore not only the structure of the software, but also what is the behavior of the software, because it's radically different. And I think this kind of a different lens on traditional architecture versus agentic architecture or AI architecture tells us that there are different types of use cases, and at the same time, both of them are very important. So let's take a quick look at how we traditionally build applications. That's on the left side of the slide. We'll see, and there's very little argument there, that normally we have ability to combine data with some sort of a logic, right? And that results in an action. The important point about this kind of approach is that it's very predictable and repetitive, right? We always know that by combining several sort of steps, if then else, or whatever logic we have, we're going to obtain a certain result, right? And we can repeat it as many times as we repeat it, we still get the same answer. We can describe this as sort of like deterministic behavior, right? Traditional systems are deterministic. A good example of this would be something like, in a bank, I'm moving certain amount of funds from one account to another. Well, we want to make sure that this operation happens completely reliably and repetitively, of course, especially with money. On the flip side, if we look at how agents operate or how digital brain drives the process, it's very different, right? It's based on a notion of we give the digital brain context and intent, and then digital brain sort of like figures out what is the next step to do, right? And that's a very different type of behavior, which we can sort of describe as probabilistic, right? It may happen to go in the right direction. It may make an error. And we really don't expect it to be repetitive in a sense that you probably have, all of us have experience with ChatGPT where you do the same question, you ask the same question several times and you get a different answer every time, even though all answers are correct. So a good example of a probabilistic behavior is something like, you're traveling with a credit card, you make a transaction, and then at the back-end system, the system decides, well, is it a fraudulent transaction or it is not, right? And the way it decides about that, it processes a lot of historical information, geographical information, when was the last transaction, and then it sort of like rates this transaction as probably like 10% fraudulent. And the system decides, well, if it's just 10%, then we can authorize it. But if it's 15%, then it's suspicious and we're going to block it. So this notion of deterministic and probabilistic is actually quite relevant to our further discussion. So if you can just put it in your mental box somewhere to come back to, we'll explore it in a minute. And it's very pertinent to the discussion around MCP in the right architecture. So remember this deterministic and probabilistic. So now let's switch gears a little bit and define what is MCP, where does it fit in an overall picture of things. And it's quite simple. If you follow the landscape and ecosystem of agentic AI or architectures in general, there are lots of acronyms which are popping up almost like every week. And the important ones on this picture deal with the means of agents to interact with each other. Because as we're initially practicing by creating a single agent and seeing what it can do, right? Then the next step, and some of the applications already are starting to do this, how do agents cooperate and collaborate, and how do they do things which are more powerful, right? Ideally, you can imagine, and there are some systems which do this today, where you can look at you can look at the systems that are put together, and there are thousands of agents collaborating on very small tasks, bringing that together. So if we look at the overall picture, there are a couple of standards and protocols which are quite important. One of the first one was A2A, which is agent-to-agent communication. Then there is something called human-in-the-loop framework, which allows agents to communicate with humans. Then a few months ago, Google came out with something called AP2, which is agent payment protocol. You can see it depicted on the right side, where you can start doing transactions. And this is sort of like all of these are supported by big players in the industry, right? So for instance, with Google, you have PayPal, you have Visa and Amex supporting this sort of like new payment rails for agents. So agents can exchange value with each other in order to transact and do other things. Another interesting standard is some called ACP, and that's something that OpenAI came out literally a few weeks ago, where you can start doing commerce within the context of your interaction with the agent, right? Again, very interesting. So, and that's where MCP plays a very significant role, and that's why it's a great topic. So what MCP allows you to do, as I mentioned before, MCP stands for Model Context Protocol. And what allows us to do is for agents to interact with resources, right? Resources is a pretty broad topic. Resources could be anything. It could be databases, it could be files, it could be services of some kind. And agents can really affect your digital reality in that sense. So that's why MCP is really the important topic for what is it and what role does it play in an enterprise. And in the next couple of slides, let's get a little bit more technical, right? And really define what MCP is in the context of agents and digital brains, which are LLM. And that gives us a little bit of a vehicle to move forward.
Boris, can
Yes.
you speak about the where these protocols originated? Are there more about consumer needs? Are there more about enterprise needs? Where are they evolving more?
Yeah, thank you for jumping in there with that question, Yuval. So it's interesting, right? So most of the protocols, because everybody, the first in any kind of industry, and this is my perspective, right? People may have different perspectives, are more interested in monetizing their investments in infrastructure. As everybody knows, billions of dollars go into developing the models. A lot of initial investments seems to go more in e-commerce. B2C arena, right? How can you monetize the user experience? And that's why OpenAI and Google are jumping into it. But what we see in the industry is that MCP is really the one of the drivers for AI enablement in an enterprise, right? So any product that you look at, including ours, is coming out with MCP capabilities. And that's where sort of like the next phase is within the enterprise. How do you take advantage of agentic AI with a protocol which is standardized across different technologies, right? And that's why it's both important and exciting to be a part of this sort of like development stream, if you will. Does that answer your question, Will?
Yes, of course.
Great. So let's take a quick look at what is the next level of detail with MCP, and the concept is very, very simple, right? So there's a little bit of a challenge which initial developers have faced with the models. If you go back a few years, probably like 3 years back, that you have a model, and one of the first models were GPTs, and the way you interacted with it was through through the APIs, right? So you have client API and you ask questions, you get answers. But the models like OpenAI models or any other model, Frontier or open source models, are normally hosted remotely, and they're stateless, meaning that they know nothing about your surrounding, your resources. And there was a question, so how do you communicate what you have locally with the model so it can act on your local environment, right? And in the beginning, there was something called functions, right? Functions over a little bit of time became tools, or they coexisted for a while. And now terminology is pretty much all moved to calling this capability tools. But what effectively functions and tools are is a description of your local functions or resources, which you built into the prompt of your request. Prompt is a description of what you want to ask the model, and then the model knows and reasons that it selects the proper functional tool depending on what it does, and it sends back the request to actually execute or exercise that function. So if we look at an example, for instance, let's visualize that we're part of a small trucking company, right? And we have these services running inside of our environment. One of them is tracking the vehicles. Another has a list of drivers that we have, and yet another one can figure out what the weather is. So we would register these types of functions that access the resources, let it know to the LLM, and then the LLM would properly execute each one of those functions to give us a more complete answer. So for instance, what we can ask is a combination of a question which combines the need to access every one of those resources, and then it combines all of this together. So all of that works, but it sort of like puts a lot of pressure and work on the developer, right? Developer needs to know what it wants to accomplish. It needs to properly sort of describe the functions, describe the action, and then LLM acts on that. So here comes MCP, right? And MCP is a very similar concept, but it moves the task of defining what a particular resource is capable of from the developer to sort of like resource owner, right? So MCP, and Yuval later on will dive into this and show us a little bit more detail, but MCP is effectively manifest, a description of what a particular resource does in a way that sort of combines tools and more context and prompts and other descriptions that describe a particular resource. And that manifest is then registered with an agent or whatever the application is sitting between us and the digital brain, the LLM. And you don't have to do anything else, right? The agent communicates, picks up the manifests, registers them with the model, and therefore model can reason across all of those resources to pick out what it needs to do and what needs to execute and how, and is able to interact with those resources. So the benefit of this approach is quite simple. We're pushing, we're sort of like making this approach much more scalable, that you can declare your resources something that a model can work with, and then the model or agent is responsible for actually reasoning and picking out what needs to be done in a certain point in time to accomplish the task. So that's a high-level description. Yuval, any kind of thoughts, comments on that? This is, is that how you see the evolution from functions and tools to MCP?
Yes, and I think it meshes with your idea that in the future everything will be driven by an agent. If your manifest is detailed enough and has all the information the agent needs to go with, it might work. I'm, of course, a bit more skeptic of when we get there and how much we can rely on statistical solutions. But it's the destination is set. We're on that trajectory.
Well, I'm glad we agree on that. And you're absolutely right. I'm a little bit more optimistic around, how fast we're going to get there, but we'll see. So the thing is that this is very exciting times that one way or another we'll find out. And that's
and I think MCP also behaves as a bridge until we fully get there, because MCP can abstract all the shiny new systems that suddenly turned legacy. It can abstract them and expose them to LLM, so you can leverage your existing infrastructure.
Absolutely. Great. So let's just pause for 1 second. I'll have to go a little bit faster to make sure we have plenty of time for the demo. But two points which I think are valuable from the slides we just went through. The first one is that there are two distinct behaviors between traditional systems which are deterministic and AI-driven systems which are probabilistic, and therefore that defines the kind of use cases are good or not good for AI. That's the first point. And second point is just MCP is, just as Yuval mentioned, it's a way to enable your resources to be discoverable and actionable by the model. So with that, let's jump to the second topic, which is very interesting, and that's probably one of the reasons why here is, so what does it really mean for enterprise, right? And the thought here is quite simple. So now we have this ability to AI enable, from the API perspective, any kind of resources we have in enterprise. Could be databases, could be files, could be services, and that's fantastic. So it seems like the natural approach, let's go around and let's slap the MCP on everything that we have, and then we put agent in charge, and we can go home and drink coffee. Unfortunately, it doesn't work that way. So and let us dive into this a little bit further. So imagine a slightly more enterprise-ready example where we have like a little bank with multiple systems in a back end, and a couple of notable systems. For instance, we have credit cards processing, and we have deposit accounts, right? What everybody's bank has. And let's say we want to ask a very simple question, right? That we have a customer, her name is Jane, and we or Jane wants to find out what is the last, let's say, 5 activities that Jane had in a bank across all of her different types of financial instruments, right? Cards, accounts, and so forth. And when agent is in charge, this involves a number of steps. So first of all, agent needs to go to some sort of a customer database, figure out where Jane is, what accounts she has and where, what are the numbers of accounts. Then it has to step back, figure out what is the data model of a credit card database, then do the same with loans. So there are multiple steps that are involved in this process. And this is a critical point, right? We're in the beginning of this talk, we've discovered that traditional systems are deterministic and agentic systems are probabilistic. So the danger here is that we're relying on AI to have a sequence of operations which have a probable outcome, and therefore they're not very precise, right? So there are several drawbacks to this approach where AI agent is in charge of effectively data integration, right? And some of the challenges are first of all, it's a very expensive process because you're spending tokens on things which are not very productive. You have faster ways of getting there. Secondly, it's error prone because you don't know whether the outcome of this process is actually accurate. And lastly, in terms of security, you may step all over the data. Jane may become Bill, or it may become Jennifer. So you can accidentally, not you, but agent can expose data which you don't really want to expose to anybody.
And especially in the enterprise environment, security, it's almost backwards in priority. So you have to think about security first, then about errors. Of course, you want your cost to go down, but security breaches enabled by AI, whether with an error or without, are a huge nightmare. So solving it on the architecture level is is almost mandatory.
Absolutely. And it's sort of like if you look at the enterprises, any kind of optimization or streamlining and saving money is very important. But at the same time, if there is some sort of event which exposes customers' privacy, it does incredible damage to the brand, to the companies, and so forth. So that's a big concern in general with agents. How do you control what they step on, what they can, not only what they can do, but what they can see and how they can affect this information? Absolutely. So here's, we just defined that it's not a good thing to have agentic AI in charge of sensitive processes, especially data integration, right? So what is the answer? And the answer is, everybody sort of agrees on, right? But let's spell it out. What we want to be able to accomplish is have AI-ready data, right? And let me define what our AI-ready data is. And by the way, there are AI-ready is used in several contexts, one of which is AI-ready APIs, and that's MCP essentially. But AI-ready data is something a little bit different, or actually quite a bit different. It's the need to be able to align data or organize data in such a way that it's most easily used by an AI, right? Whatever it means, right? So that's the high-level definition, whatever it means, for a particular set of data. So AI we know now, right, is very strong in reasoning and probabilistic actions. It's not very good in assembling the data. So AI-ready data is very important. But how do you accomplish AI-ready data, or how do you get there? And the mechanism, which is now everybody's starting to converge in industry on that, is something called data products, right? We're not going to go into data products in detail here. You can see these little cubes on a slide. That's how we depict them. But it's not our term. It's an industry term. If you haven't heard about this, I encourage you to look into it. It's a very powerful new approach to organizing data. And just spending a minute because I'm on this, because I think it's an important point. If you look in the past, there was a concept in programming called object-oriented development, right? And all of us in school or in practice went through this exercise of sort of like what is it and how do we work with it? And if you remember, object-oriented programming is combining data and function together. It's encapsulated. You don't know how the data looks like. You don't know how the function actually looks like. You just see the interfaces. So data products are very much like that. They're almost like data objects. Rather than object-oriented programming, we have data object-oriented programming, with a slight difference that there is no, you act on it, right? It just contains the data. And the question is then, why is it the data product rather than the data object? And the reason for that, because one of the fundamental premises of data products is that they are managed as software. They're production worthy, if you will. So they're highly governed. There are teams of people that working on definition, on maintenance, on curation of those. And together, that is the concept of a data product. So if you're curious, please look into that. It's a very interesting, important approach. And that's what K2view practices, right? We effectively deliver, specifically in the world of AI, for AI-ready data, we're delivering a data product platform which allows you to do data integration across your existing resources and effectively lay out data in a way that is AI-ready. Right, so that's a very high-level view on that. Yuval, we don't have much time, but any kind of quick comments or thoughts on that?
No, I think you nailed it. Data products are AI-ready, I think, for two reasons. They bring the data the AI needs. They bring only the data that the AI needs, and not more than that. And that's the big part of solving the security aspect of this architecture.
Yeah, absolutely agree. So with that, let's quickly move and make this sort of, let's double click into that point of, so what is the right architecture for AI access and for MCP, and how does it all come together? And we'll take a little bit more enterprise-friendly example. So let's say we have a number of different types of resources in our enterprise, right, which deals with different types of applications. legacies, mainframes, and so forth. So the first look at this is, well, fantastic. Each one of those, or many of those, already have MCP servers. So just in terms of terminology, you probably know that in MCP language, right, you have the notion of a server, which wraps up the resource, and then you have a notion of a client. That's what contains the business logic of interacting with the data. And the initial sort of naive approach, if you will, is to just expose those resources through the MCP service and allow the client application to actually do data integration as well as reasoning. So where we would like to get to, and that's the next slide, is a different configuration. We would like to have the server be responsible for combining data from multiple resources, effectively materializing instances of data products so they are ready to be worked on by any kind of a client. And then rapidly moving, so how do you accomplish that? And that's where our platform is an example of a platform which does that for living, if you will, right? We haven't started just specifically working with AI. This problem is quite broad and very well known in the industry, but it's in our eyes, it's a perfect alignment of ability to combine your resources and making data to be AI ready. So you can see the layer of data products in this blue box. That's one of the components that we have. You can see the MCP server, which allows sort of this declaration of AI-ready data to the different types of clients. And going into a little bit more of detail on this, and that's what we're going to explore as the next step together with Yuval, is what's on the inside of that block, right? And this is sort of a more concrete diagram of what enterprises do and what we're going to explore in the next few minutes. And you can see multiple enterprise resources in the back end, and ability to collect data from all of those resources into instances of data products, which are sort of perfectly aligned in the context of those back-end systems and the interface that the data product defines to be used by downstream applications. In this case, it's agentic AI. This is really the conversation that is very important for everybody to move forward, but also sort of like a jumping off point, if you will, for us with the demo. Yuval, I don't know if you want to comment on this slide or just move directly into the demo.
Maybe by way of an example, if you look at an ERP system, it's immensely complex. And if you look at a specific use case to navigate through that every time you're asked a question by an end user, that will be an extreme undertaking. Whereas once you encapsulate the data needed for a specific agent in a data product, you're effectively exposing ERP data to the agent, but in a way that is speaking the business term of the agent and not the semantics of the underlying system. So I think you will always need this integration layer between your agents and the actual source system. So definitely a valid approach.
Great. So maybe it would be great. We've talked about this. We talked about the theory, and now is a good time to dive into and actually see what this looks like.
Yeah, sure. So let me share my screen. Hopefully you can see it. Boris,
yes,
are you able to
yes.
see the screen? That's great. So I'll give a very brief intro to data products. I'll leave most of the time for MCP and very cool AI interaction. What we're seeing here is K2view's platform with the studio in front. And the studio is where I design my data product. So what we are actually seeing here is a small data product representing a bank, a small bank, more specifically a customer in a bank, customers, or even more specifically, a specific customer in a bank. So this is the way we model data products for such use cases is we model them around a specific entity. So when we pick data, in this case from the CRM, let me get this a little bigger. From your CRM or from the loan system or from the tax system, credit card system, etc., it's always with a notion of the entity. In this case, of course, customer. So I'll start from the end. So we model the business entity. We know what it is. If I look at one of these tables for customer number 1, I will see the data that belongs to this customer. And this is a whole integration platform that brings data just in time, fresh data, and exposes it to the outside world. And what we've added is the ability to expose this data as MCP. So far, this is the data product approach, and we've exposed it as MCP. So the first thing I'm going to show you is the MCP inspector. An MCP spec it's an off-the-shelf open source tool, and we can look at an MCP server. And the first thing I want to show is the fact that we're connecting to the same environment, right? We are in the same space here, but if we're looking at the full URL, we're connecting to the MCP of customer bank 1. And when we talked about security, Boris, I think this is the crucial ingredient we've been looking for. So I'm not connecting to the entire data set with this MCP server. I'm specifically connecting to customer number 1. And assuming my authentication credentials are giving me access to this customer, I can now connect to this MCP server and view resources, prompts, tools, etc., that belongs to this customer. So this is how we approach fencing data within an MCP server architecture. So very briefly, so we're going now into the details of what an MCP server looks like. It has resources, prompts, and tools. It has a bit more routes, authentication, elicitation, etc. I'm not going to go into all of that, although all of them have bearings on our data product. But resource, prompts, and tools are the prominent ones. So what are resources? Resources are the tables and schemas that define my data product. The MCP client can consume these and know how to interact with my data. And when we expose these tables, it's still only metadata, but it's well annotated metadata. It's metadata that came from our catalog and discovery systems and additional user input. All of that information based on names and data sampling, et cetera, is now exposed as tables and schemas to my MCP client, and of course all the relations between the tables. So we have a strong semantic layer for the MCP client to work with. We can introduce prompts and have them readily available to our MCP client, and most importantly, we have tools. So the basic tool is we also expose our schema using a tool. Not all MCP clients know how to consume it from resources, so we can consume it with a tool. And I'm going to show here something very silly. I will show a query. So this is how an MCP client would go about selecting this table. Select star, it will probably write it correctly, and it will see the data. So we're not going to see any of that when the actual MCP client works, when Claude does its thing. But behind the scenes, this is what's happening. It's querying, it's using the table and resources to understand the metadata and the relations. And we also exposed a few additional tools using our orchestration platform and bundled them with this data product. So it also has access to things like credit card limit, that is something that's calculated, and even a knowledge-based data retrieval, which tells its thing about our little bank and how it operates.
Right? Yuval, I have a quick question on this before you switch the screen. So just to understand, this is a third-party tool which allows us to introspect into our MCP server and sort of discover and walk around on what the capabilities are. So the question is, can it do it with other sources, like other MCP servers as well?
Yeah, so of course, this can work with any MCP server. It can be used to test an MCP server, and it also can connect to multiple MCP servers and use them in conjunction. Here I'm just showing it as a way to demonstrate that once I have my data product, automatically now I have an MCP server on top of this data product.
And not to digress into that, but when you shown the data product interface in the previous view that you saw, how did you come up with those?
So again, this is we didn't want to go too much into data products.
Just a little bit, yeah.
But very briefly, what we do is we build a catalog of all the resources in an enterprise environment, and using that catalog, we build a data product. A data product can be, of course, a subset of the entire catalog. It can also be a mapped version. It doesn't have to be a one-to-one copy of the source data. It can be massaged and mapped. Here we did a combination. We copied most of the data and relations as they were discovered by a catalog and created a subset of that as a data product. And for some of the tables, we even did some changes and massaging to make it simpler and more available to our trusted AI.
Got it. So this is more of like a result of data integration, and now we can see that interface show up on the MCP side as a interface definition in MCP. So there is a strong connection there.
Exactly, and we've abstracted away some of the complexities that come with a full-blown CRM system or a full-blown demand and deposit account system.
Yep, thank you.
All right, so we've established our MCP server. That's, it's almost like a simple API explorer. But this, because Claude knows how to operate with that, this gives us a very, very powerful mechanism. So here I have off-the-shelf Claude, but we've introduced the same MCP server as one of the tools available to Claude. And I will ask it, hi, please list my credit cards. All right, let's hope AWS East 1 doesn't go down today. All right, so we're seeing some very interesting things. So first we see that it already knows automatically how to invoke my MCP server. It's calling the table. It understands my needs, and it also can invoke the tool. And it gave me some information about my credit card. So here, again, if we drill down, a very simple data query, and I'm seeing a balance of 3,000. So how did I get to 3,000? All right, so now it's looking at a transaction history, and it's actually telling me a bit more about what's going on and how did I get to 3,000. And as you recall here, my credit limit was 4,500, so I'm a bit worried. I want to raise my credit card limit. I want to raise my credit card limit to, let's say, 5,000. All right. So again, it's checking my eligibility, and the way it's doing that, and it's invoking the tool, and it's also using the prompts we provided to know what's the procedure to raise the credit limit. So it went over my credit score, and it's looking at my banking information and the banking rules of engagement, which are of course simplified for the sake of the demo. It knows that it can raise the limit, but it's asking on which credit card, because I was indeed a bit ambiguous, but let's just do both. So now it's calling the tools which we provided with the MCP server to update the credit card limit. And hopefully it went well. Yes, I've got my new my new limit. But maybe this is not a great card for me. So I'll ask another question. Maybe recommend a better card for me. All right, we're getting to some very cool stuff. So it's looking at the inventory of tools, and it's finding out what's going on with my transactions and what are they eligible for, and it's explaining its thought process, and it's asking if I want to see cards that match this, and now it's invoking the knowledge base, which we provided is one of our tools. This is the knowledge base of everything we want to explain about our elite bank. And the best match is the gold cashback card. So this is, but there are some alternatives. So this is how the MCP server over the data product enabled the MCP client to go through all these very nice demo. And the idea is that this is not specific to this MCP client, right, or to this agent. So maybe this agent, if you look at it from a banking perspective, you don't want Claude to be your front end for your users. You don't want to lose so much control. You want to control it tighter, and you want your own agent. So this same MCP server is now interoperable. Here I'm showing our K2view's MCP agent and MCP client, sorry. And again, I asked the same question, actually got a very similar answer, which is very interesting, but I did it in a more controlled environment where there are more controls, a more enterprise grade client where everything is audited. I can see the full conversation that's going on between the client, the customer, and the LLM, not just the MCP calls. I can even get better trace on what's, how did it get to that conclusion, et cetera, et cetera. All the tools, the safeguards, and the observability you need for an enterprise solution. So any MCP agent can get to similar results. And the idea is that once you expose the data product as an MCP server, you can reuse it by multiple agents. Boris, what do you think about that?
I think this is very exciting in terms of technological building block. But I still had a question just to refine it. That in your demo, we had this fictitious bank, right, which contains all this information. And then we tried different type of agents, and these are not the agents which are very complex and they interact with anybody else, but these are very simple agents. In one case, it's Claude environment, which uses a client interface, but it has agentic capabilities, like it takes context, it figures out what to do next, and so forth. So you use generic Claude environment to just demonstrate that it can connect and work with the backend, which is MCP wrapped. And we provided the integration, we provided the data product, we provided the MCP, and then Claude does it, right? And then the second demo is an example of another client, which is probably more enterprise ready, which we happen to have as a product as well, right? And it allows you a more structured way to describe the context, understand what is being done, understand and log the behavior, probably manage multiple agents and so forth, just so we have a clear picture.
Yes, of course, something as simple as analyzing all the chats and getting a sentiment analysis is something on an enterprise grade solution you have to have out of the gate. Whereas if all you do is expose MCP an MCP server to the outside world, you lose a lot of that capability. And I think this is what differs the MCP approach taken by the consumer by the consumer ecosystem versus how enterprises can adopt it for their needs, either for internal architecture or even B2B. It all has to be much better regulated and controlled than the consumer space of Claude and OpenAI. It's anyone's guess where it's going next, but for sure, enterprises will need a lot more control than Claude can offer them at this point.
Sure. So, I mean, clearly, this isn't probably everybody understands that that's not a realistic example. The bank will not rely on MCP or Claude or anything else to actually transact for you. But maybe this is a good jumping off point. If you can share an example and you have a little bit more information on that. So there are good use cases as we started this talk. There are good use cases, there are bad use cases for agentic AI, right? So clearly banking is, if we map back to this deterministic probabilistic model, is not a good application to begin with. But what are the good applications? And maybe you can give examples you have a little bit closer to that, things like customer support and so forth, and maybe example of applications we actually support, which could be useful.
So we do have great great overall experience with customer support use cases with our early adopter customers, and I would say the idea of softly going into a more deterministic experience is something that we see a lot. So I want to kick off a process, a very deterministic process, but I don't know, how to approach it, even in enterprise environment. I want to kick off a data pipeline. I want to get at a specific data point. I have a question, and I don't always know which tools are available to me. And so this approach of starting with natural language and then at some point kicking off a deterministic process using this MCP bridge, we see that as a very strong use case across multiple customers.
That's great. So you see, like you mentioned, that it's not yet the time, but it seems like this is the time. We're starting to see the examples of things moving forward.
It is.
Great. So listen, we have just a little bit of time left. I want to put up a slide that we ended up on, which is this slide. Let me see right here, I believe. Just to summarize what Yuval just shown us, right? He's shown us Claude as a client. He showed us GenAI, which is GenAI Fusion, which is K2view's sort of like agent on the top of the MCP services that we provide. But also recently, OpenAI came out with their own environment to build agents. So there is truly a renaissance of the building tools, if you will, and therefore on the other side, there is ability for us as technologists in this space to provide AI-ready data to those types of environments to start building interesting applications. So fantastic. We have just a few minutes left. A couple of things before we jump into questions. First thing is that if you want to go to the attachment icon on your screens, there's a number of resources that is available for download for you, which is, I think, the slides, this recording will be actually sent to you a little bit later, but also a certain blog and publishing around MCP, so some materials that can be useful to you. And with that, maybe we can jump into questions. There are a number of excellent questions. Thank you. I don't think we can cover all of them, but there are a couple of good ones that we can address right away. So one of the questions, Yuval, maybe you can take on that. Very simple, but a profound question. Is this like WSDL for the agent world for APIs? What is the comparison between WSDL and MCP in your mind?
Right. So in a sense, yes, it is a way to expose my capabilities. The difference between a WSDL and an MCP server is that a WSDL has to be consumed before you start the interaction, right? Someone has to prepare it in advance and create all the code that interacts with the WSDL, and only then can you run. I would say an MCP is somewhere between a WSDL and just pure documentation of how I would expect you to talk to me, and it can be consumed by a large language model and decide on the fly how it will activate and get to a specific result. But I would say in this architecture, yes, it is taking the place of a WSDL, the WSDL took in the very old architecture of SOAP APIs.
Excellent. Thank you. Great answer. Another interesting question, which is probably, you can spend a long time debating it or brainstorming around that, but is using an MCP making my architecture more modular and interchangeable?
So I would say yes, in general, in principle, sorry. Yes, because MCP clients are an open standard, other MCP clients can consume your MCP server. I don't think we're at a point yet where an MCP client out of the box would work 100% of the time. MCP servers have a very good definition. MCP clients, not so much. So there's still some interoperability issues, but it is a very good first step. And MCP clients might need some adjustment. Just as something we've seen, Claude is not very good at deciding to consume resources, whereas Claude Code really starts by looking at the resources. So it's a different decision of how they work, and that affects how you present data in your MCP server.
Excellent. The last question before we will need to sign out, but the question I think is very good and something you touched on already. And the question posted is, enterprise data is very sensitive, contains information about your customers, etc. How does entity-based approach or data product approach ensure that data security and privacy when using MCP? Maybe you can just another few thoughts on that.
Yes. So in a sense, it is the fence around the data. It's not. It's a core principle. There are other aspects to it. Column level and row level security come to mind. But this idea that you start with the modeling the entity and not looking at tables, rows, columns, but actually what is the business entity you're looking at, specifically the instance of the business entity. I'm looking at customer number one, like we did in the demo. That means that by definition, the LLM cannot go outside the zone you've set for it. Even if the statistical engine failed, even if someone tried to manipulate it, it still cannot physically go beyond the boundaries that were set to it in its authentication and authorization parameters. Without this modeling upfront, it's very hard to keep the consistency of how do you both allow the LLM to travel the data freely, but make sure it doesn't take a wrong turn somewhere and ends up with the wrong customer or the wrong invoice or the wrong payment for the invoice, etc., etc.
Got it. That's excellent. Excellent answer. Listen, we don't really have much more time for answers. Let me just summarize that our intent and hope here was to just trigger some thoughts in everybody's mind in terms of the trends, the options, the tools, but would love to have deeper discussions with you if you're interested. So for that, if there is a poll attached to this to the screen that you're looking at, if you indicate in the poll that you'd like to have sort of additional discussion, dive into the broader demo, please click on that poll, and we'll get in touch with you and arrange for deeper dive into this and discussions and listening to your experiences. But other than that, thank you very much for your time. It's been a real pleasure to be speaking with you. And Yuval, thank you very much for your thoughts and a wonderful demo. And we hope to have continuation to this, and discussions will move forward. Thank you. Thank you, everybody.
Boris.